a wave, and a straight line sliding up through it. Watch the meeting points. 4, then 2, and up here none. The line misses the wave completely. Real exam questions ask, at which heights does the line miss completely? Hold that question. An angle theta opens anticlockwise to a point, P across, Q up. Tangent of theta, Q over P, its live value sits here. Now go negative. The same ray swings clockwise below the axis, and the point slides to P minus Q. Only the y-coordinate flips, the tangent just changes sign. Candidates flip the fraction to P over Q, a different number entirely. The picture says minus Q over P. The sign flips, the fraction never turns over. Cot x equals cos x. First move always, rewrite the reciprocal in sin and cos. Multiply up by sin x. Both sides now share cos x. Here is the fork in the road. Left path, divide by cos x and it vanishes. Right path, gather and factor it out. The true answers lie at 90 and 270 degrees, where cos x is 0. Dividing deletes every answer inside cos x. Only 90 crawls back through sin x equals 1, 270 is gone. Factoring keeps every branch. 90 and 270 both survive. The rule, rewrite in sin and cos then factor. Never cancel. One equation can hide 3 answers. First branch, sine of x is a half. Positive, quadrants 1 and 2, basic angle 30 degrees. Your calculator hands you one, 30 degrees. But sine stays positive in the second quadrant too. 180 minus 30 is 150 degrees. A second branch, sine equals minus 1, points straight down, 270 degrees. Stop at the calculator's answer and you leave marks behind. Sweep the whole cross, the whole domain every time. 2 readouts, 1 number x. Read as degrees on top, radians below. Sweep x to 6. As degrees, sine barely wakes up. As radians, it has climbed to 1, fallen, gone negative. Wildly different. The domain tells you the units. A bare pi means radians, a degree sine degrees. Choose wrong and every table value is corrupted. Plot the key points of cos x and join the wave. First, reshape. The modulus folds every negative lobe up through the axis. Then stretch, every height doubles, peaks at 2. Then slide. The whole curve drops by 1, swinging between minus 1 and 1. The trap, slide first, fold after, and you get this gray curve. It never dips below 0. Wrong shape. Order is part of the answer. Fold, stretch, slide. Keep the finished curve. Now we interrogate it. A line sweeps up with a live count. Below the floor, 0 never touches. The count first wakes at the minimum, minus 1. Pin it. Inside the band, the line always lands somewhere. The last change is at the maximum, plus 1. Above, nothing. The algebra agrees. Fold, stretch, slide the cosine band, and the same minus 1 and 1 appear. Example 1. Solve cos 2x equals sine x from 0 to 360 degrees. Degree signs work in degrees. Different angles cannot talk. The double angle identity rewrites everything in sine x. Substitute 1 minus 2 sine squared x equals sine x. Bring everything to one side, a quadratic in sine x. Factor never cancel. 2 sine x minus 1 times sine x plus 1. 2 branches, sine x is a half or minus 1. Sine positive, quadrants 1 and 2, basic angle 30 degrees. 30 degrees. And 180 minus 30, 150 degrees. The second branch is sine's minimum, straight down, 270 degrees. Sweep complete, every branch the whole domain. 3 answers, not 1. X equals 30 degrees, 150 degrees, and 270 degrees. Example 2, the Hooke's question. Sketch this curve from 0 to 2 pi, for which k is there no solution. A bare pi, so radians. Build the curve in the locked order. Start from cos x, key points first. Fold the negative lobes above the axis. Stretch doubled so the peaks reach 2. Slide down 1. It swings between minus 1 and 1. Read the curve. Floor minus 1 at pi over 2 and 3 pi over 2. Ceiling 1 at 0, pi 2 pi. Confirm with algebra. Fold, double, drop the cosine band between minus 1 and 1. They agree. The line y equals k always lands inside the band. Above 1 or below minus 1, it misses forever. The amber no solution zones. The hook paid off. The line misses the wave above the ceiling or below the floor. No solution exactly when k is below minus 1 or above 1. So when does the line miss the wave completely? Above the maximum or below the minimum, here above 1 or below minus 1. That is the whole chapter. Rewrite cot, sec, cosec into sin and cos, then factor never cancel. Sweep the A, S, T, C cross across the whole domain. Check degrees or radians first. Build graphs, fold, stretch, slide, then read the minimum and maximum off the curve.